Hi, everyone. We're going to start the next session. Please sit down. So in this second session of today on practical implications of cryptanalysis, we're going to see the first talk on a more practical attack against Yoroi. And the talk is given by Ruao Wei. Thank you very much. Now.
Okay, thank you very much for your introduction. I'm Ren Wei from Shandong University. I'd like to talk about a more practical attack against the euro. Here is the outline of my presentation. So we have three sections: the preliminary, previous work, and our work. Okay, let's move on the first section. The topic is about white box cryptography. The white box setting is an untrusted environment. In this setting, the actor controls the environment, and he can observe everything inside the encryption, and even modify its implementation. There are two main attacks in this in the white box setting. The first is the key extraction attack. The goal of the attacker is to extract secret key from the program, and the second is the code lifting attack. In this case, the attackers target the function modulars of the program. By extracting the modulars, they aim to replicate the functionality of the program for their own purpose. A space-hash cipher is a specialized white box cryptographic scheme. Designers use large S boxes to resist code lifting attacks. This kind of ciphers can maintain security even when some entrants of the S boxes are leaked. However, the designers didn't account for the scenario where an attacker receives the leaked information and conduct analysis in the black box setting. To do an SOB proposed point that if such an scenario is not taken into account, the application of speed-hard block cipher will be severely limited. So they proposed the hybrid attack model at FSE 2023. This model comprises two attackers. The one is the white box attacker, who hacks into the encryption program and can do everything against it. The purpose is to leave some information to the outside. The other is the black box attacker, who receives the information and analyze and conduct the analysis in the black box setting. They apply this attack model to the space hard block cipher, successfully breaking Uriel. Here is a brief introduction of Uriel. It's a block cipher based SPN structure. Its linear employs large S boxes, while its non-linear employs large S boxes. Its linear is partial and is and only applied to the low T bits of the S box outputs. Finally, a 4-round AES is applied. Euro is an updatable block cipher. In its white box implementation, T1, T2, and T3 are used. If the block cipher is insecure due to excessive table entrance leakage, replacing the permutation EK is enough to restore security. Thus, Euro is capable of resist to continuous leakage attacks. The second section is previous work against Euro. In this section, we will briefly introduce the hybrid attack against Euro by Todo and SOB. In their work, they propose a chemical representation of Euro. An ambit permutation is applied to the lookup table and can be cancelled in the next round. In their in the work of the in their white box phase, the attacker modifies the canonical representation, modify the original cipher to the canonical representation, and leak some table entrance and the key of AES to the outside. In the black box phase, the attacker receives the leakage and analyze the Eurocode in the standard black box phase, where Eurocode means euro without AES. And then they use the two distinguishers to use the two distinguishers recover the the output of the table entrance, and their attack in the in this phase is conducted in the chosen plain text setting. However, considering a strong white box complexity is not easily achievable in real world scenario. So we weaken the capabilities of the white box attacker and propose a more practical attack against the Euro. Okay, let's move on our contributions. In our attack, we only leak the key of AES, and we didn't modify the implementation of the cipher. So the calculations in the white box phase are completely eliminated. And in the black box phase, our attack is conducted in the chosen plain text and several text setting with complexities comparable to the previous work. In our attack, we first analyze the linear matrix of we first analyze the linear matrix of Euro, and discover that adding a fair transformation before and after it can preserve its functionality. It means the same input will produce the same output. Based on this discovery, we propose the equivalent representation of Euro, an arbitrary ambit permutation, and an arbitrary t-bit transformation is applied to the lookup table. Then our goal is to recover an recurrent representation of Euro, that is T1 hat, T2 hat, and so on are used for each round. Now I will illustrate our attack process by using the recovery of T1 hat as an example. We first divide the input space of T1 into subsets. Elements within the same subsets produced from T1 sharing identical low T bits, but the specific value is not known. So we assign a unique random value to these subsets. Then our purpose is to find a permutation applied to these random values that satisfies the equivalent representation of Euro. There is a shortcut during this process that we need not exhaustively search through all the t-bit permutations. Instead, we just need to traverse the permutations that are affine independent. Then how do we find the correct permutation? Our purpose is to first collect some correct pairs. The correct pairs satisfy the truncated differential path. Now we focus on the first round. The output difference of the linear only actives in the high t bits, that is beta 0, 0, 0. And applying the correct permutation to the random values we assigned is equivalent to applying a t-bit affine transformation to the original lookup table. So under the character permutation, the difference of the output difference of the line list would also active only in the T bits. So we can save the character permutation by checking the output of difference of the line layer under the character pairs. So how do we get the correct pairs? Our method is prepare a ciphertext structure that meet the output that meet the distinguishers the output and request for the plaintext. If we pair these plaintext, there would be some correct pairs. Then we need to pick them up. Next, we extend the plaintext pairs by modifying them only in the first in the first T1, ensuring that the low T-bit output is unchanged. Through this way, the plaintext pairs derived from the correct pairs must satisfy the input difference of the distinguisher. So they are more likely to satisfy the output difference of this distinguisher. So we can pick them up by check the difference. Now it's time to recover the high-end bits. We use the correct pairs and this distinguisher to divide the input space of T1 into subsets. Elements within the same subset share produced from T1 sharing the same high-end bits. Since the line layer doesn't affect these bits, since the line layer doesn't affect these bits, so a unique random assignation to these subsets is enough to recover a equivalent URL. At this point, a new lookup table T1 head can be recovered, and the attack process for the other round is similar. As a result, a 4-round equivalent URL can be recovered. Okay, that's all. Thanks for your attention.
Thank you very much. Are there any questions in the room? Yes, Isuke?
Thank you very much, Doc. So this time, so the leakage size is now only 128 bits. So it's only AES key. So I think it's a very difficult to improve anymore. But so I have the question. My question is, so that do you have any idea to counter the DAC?
Counter the DAC?
Yeah. So actually, so it's a very so now so that we have practical DAC, so that we want to modify the specification, and is it possible to get nice countermeasures for the attack?
Sorry, I can't get it. What means the DAC?
Like
Yeah. So
to repair, right? No?
Yeah, how to fix?
How to fix?
How to fix the specification of your OI?
Sorry, I didn't consider this question.
Okay.
Okay, thanks. Thank you. Another question there, please.
I'm sorry, maybe I can answer the previous question. Actually, I think we can input the AES layer in the middle of the URL code layer, yes, there are 5 URL code round and AS and 5 round AS. Sorry, and 5 round the URL code. Since our attack and the previous attack is rely on a truncatable differential distinguishers, and if we can have the AS layer in the middle, we cannot find this. I think it's a possible way to conduct this type of attack. That's all. Thank you.
Thank you very much for the answer. Are there any other questions in the room? Okay, then we will thank the speaker again. Thank you very much.